Hello, welcome to Slow Mo's YouTube channel again. We are going to be reviewing for our test 4.1, which is Earth Science. So it's going to be all of the plate tectonics and rock cycle and weathering and things that we've been talking about in class. So this very first slide that I have here is going over the layers of Earth. At the top here, you've got the lithosphere, which is also known as the crust. But you need to know these vocabulary words here, the lithosphere and asthenosphere. That's important. Remember, I told you LA, like Los Angeles. Lithosphere is on top, asthenosphere, or asthenosphere sometimes, is underneath that. That's the very top of the mantle. And so then we've got the mantle there, and then the outer core and the inner core. And as you go deeper, you're going to have molten rock, right? Here we've got plate tectonics. You need to know the difference between the movements. You need to know the names of the movements. Make sure that you study that. You need to know what they're going to cause or what feature is formed. And you need to know examples. So let's start with the top one, which is divergent, right? Divergent, you can also remember that this is all about dividing. So this is going to make mid-ocean ridges. In other words, in the middle of the ocean, right, where new crust is formed, or the ocean basin. So we could think of, for examples, we could think of the Atlantic Ridge or even the Rift Valley. Subduction is a type of convergent, but one plate goes underneath the other. It gets subducted, right? So that's going to create volcanoes and trenches, like the Andes Trench, the Japanese Trench, a bunch of trenches here. And then convergent, here they're showing you two continental plates converging, and they're going to make mountains like the Himalayas. That's your example. And then we have transform plates are going to be sliding past each other, and that's going to cause earthquakes like at the San Andreas Fault in California. Here you have the rock cycle. In red, I put the main different things that it creates, and in blue, I put the processes that form those different types of rock or sediment or magma. So everything that is pointing at sediment, notice how it says weathering, right? So in order to make sediment, I have to weather. That means I'm breaking apart. Then if I want to make sedimentary rock, I have to undergo compaction and cementation. And so compaction, remember, means to squeeze like a trash compactor. And then cementation means to get glued together like cement. Then look at metamorphic. Look at all the arrows that are pointing at metamorphic. They all say heat and pressure, heat and pressure. So I need heat and pressure to make metamorphic. Oh my goodness, there is a typo there that is not supposed to be an H. Sorry about that. I will fix that before we do that in class. And so here we have to have heat, but not too much heat. And we have to have pressure to squeeze it together. So it's just a little bit melted, but not completely melted, and squished a little bit more to make metamorphic rock. And then look at magma. All the arrows pointing at it are melting, right? So now we have molten rock, and then when it cools, it goes to igneous. Keep in mind that anything can become anything as long as it goes through the right process. On to how they move. So in the instructions here, I asked you to label it with words like cooler, more dense, less dense, and hot. So remember, as I'm at the bottom, I am going to have very, very hot magma right here. And it's less dense, so it rises. It gets cool up here, so it's more dense, and it sinks. And this is all caused by convection currents. This is a convection current. And this is what's going to make the plates move. Here are the plates that exist all over the world. Make sure that you study these so that you kind of have an idea of which ones are which. It should be pretty easy as long as you recognize the land forms here. We've got North America right here, which is letter D. We've got the Pacific plate. Remember, we watched the video on the Ring of Fire. So this is letter B right here. We've got the South American plate, the African plate, the Eurasian plate, the Australia plate, and so on. Those are the major ones. I would spend time on these major plates right here on the left-hand side. Make sure you know those. Alfred Wagner, and I bet you're thinking of the song right now. So he's the one that um, discovered plate tectonics, or really he's the one that came up with continental drift. So really there's two answers here. You could say Alfred Wagner's discovery led to the theory of continental drift or plate tectonics. It's up to you what you want to write here. So there's Pangaea, right? And there's Alfred Wagner. Weathering, erosion, and deposition. Weathering breaks it, erosion takes it, deposition makes it. That's the easiest way to remember it, right? Weathering and erosion are not the same thing. Some people think that they're the same thing, and they're not. Weathering is when the rock actually breaks down, and then erosion is when it moves, and then deposition is whenever it gets dropped off. I included a picture of Texas here because you do need to know how weathering, erosion, and deposition are going to affect different areas of Texas. For example, we talked about the caves. Those are going to happen in the hill country because that's where the limestone is at, and that's where we're going to have a lot of that chemical weathering that's going to dissolve the rock and create those caves, and then create the stalactites that are holding on tight to the ceiling, and the stalagmites that might reach the ceiling. You're also going to have beach erosion by the Gulf of Mexico, which is right here. So that's because of the waves and things like that. Weathering. So the breaking down of rock into smaller pieces that remain next to each other. Weathering forms sediment. And we've got two types of weathering, mechanical and chemical. And remember, mechanical weathering is basically like a physical change. And so this is not changing the chemical composition of the rock. So physical breaking of rock without any change in the chemical composition of the rock. And I put these in blue at the bottom here just because it was really hard to fit them in there and make them big enough so that you could see them. So our 4 examples here are ice wedging. Remember, ice wedging is when water gets into cracks of rock and it freezes. And so it takes up more space when it's frozen, and that means that it's going to crack open the rock even more. Animals, because of digging, will also cause mechanical weathering. Abrasion is scraping, so wind or water can pick up sediment and scrape it against other rock. And then gravity, because it's, rocks fall and they break. Then we've got chemical weathering, the breaking down of rock into smaller pieces because of chemical changes within the rock. And our 4 examples here are oxidation, which is rust, that's when we see red rock and stuff. Water, like limestone, which we just talked about. And then lichens, remember primary succession, lichens are a little bit acidic. They have enzymes and they will break down the rock. And then acid rain was another example that we talked about. Watersheds, very, very important because we have to understand how rivers, lakes, the ocean get recharged or refilled. And we also have to know how we affect those bodies of water. So everything that's happening in the watershed has the potential to get into that river or lake or whatever. It's getting recharged in that area. So we have to remember about the pollutants and how they percolate. Remember, percolation is when it soaks down into the soil or the rock. So what is a watershed? All the water in an area recharges or refills a body of water that is nearby. Okay, so that's the end of our review. Study so that you can do really awesome on this test. I believe you, and I will see you at school. Thanks.